Alright, just checking to make sure we're going. My first video was 20 minutes long, so I'm going to go a lot quicker through it here on the second tank. It's shorten the time down. So, final project, COBOL, machine learning models for the database of movies. Important features I want to start with first. I wanted to look at feature importance, see which variables were important, what to look for, and I found that these were the top 6. Number voted by users, duration, budget, number of user reviews, gross profit, and number of critic reviews. These were really positively correlated with IMDB score, with the K-best selector, and so these were something I was kind of looking for, and you can kind of look and see some of the qualities that those had, those variables. So that was that. So then going forward, regression was the first thing I went about. So I did a little correlation analysis here, and I did a little heat map just to kind of get a better idea of how these might work with regression. So I did bins. I put them into 4 bins just to break up these sections when predicting the score. Then I dropped some certain variables I didn't find that would be important, categorical variables that wouldn't necessarily work. And this is what I got my first regression model. And I had a bunch of p-values. So a lot were 0, but then that means that we're statistically significant. You can't reject the null hypothesis. But anyways, there were some that were high, and the multicollinearity was very high as well. And R-squared was not good either. So this was kind of telling me right away that this was not the best. So I want to take out some of the models, some of the variables that had high p-value, and I actually got a worse R-squared score, but I had all 0 p-values, but the multicollinearity was, again, extremely high. So what does this tell me? It tells me that for this data set, this is just not a good way for predictive modeling, because the R-squared was even worse now, which I found interesting even when I cleaned it up. In my mind, that's what I thought would happen, was it get better, but it got worse. So moving on, I was hoping classification would go better. So I started with the K&N model, which is like Neighbor's classifier, which is a lazier method, and that's probably why I got a lazier result of 0.5698, which is 56%, which only predicted 408 correctly in the third bin, and overall 457 movies, so it was kind of a little bit all over the place. I didn't think it was that great, so I wanted to try a different one, so I went with decision tree. So here's my decision tree. It was a lot better, 70%. So big jump there, and the accuracy of the model, and I was a lot more happy with that. I got 567 of the movies out of 802 correct. There were some bins that weren't great. They were kind of didn't predict any right. Then others that were really highly centered, like right here, 480. So I was happier that I got a better accurate model, but I was going to see if I could do better, and I went with the random forest classifier. So this ended up being my best model of 71%, almost 72% accuracy. And I got 576 movies out of 802 correct. Unfortunately, this does mean that 226 were incorrect. But overall, this was a big jump from the very first regression model I did of accuracy of the model and predicting the IMDB score for the movies. Then clustering was another method that I wanted to use, and so I used K-means algorithm, and I was going to break them up into clusters. So this is me joining them, and then this is the cluster. This first method I used, I had 3 clusters, and you can kind of tell the traits for each cluster here. But unfortunately, if you take a deeper look, the clusters were not very well distributed. We see 2,300 there, and then the second bin cluster only has 3 movies. So these were the average scores for those, but it doesn't really mean too much because I felt like it was too lopsided. So I wanted to go about using a different method, this method right here of clustering. So I decided to go about it. So I split it up into 4 clusters this time, was my plan. I just felt like it would work better, and these were some of the traits for each cluster. And what I kind of found was certain these categories are kind of split up an even amount of movies, there was a lot of similarities in the clusters. I thought that was very interesting when looking at it. So you can kind of see the clusters that had, I'll go down one more here. These were the kind of distribution of the clusters, like 2 and 4 were pretty close, and if you look, the scores are pretty far off, but then if you look here, there's a little bit of difference in their stuff. It just seems like this third cluster is just slightly behind, and Facebook likes, actor likes, gross, number of video users, it's just behind. It's just second best every time, and it shows up in the score right there. Pretty big difference in the score, and I thought that was very interesting on the data. Just kind of highlighting what I found for the first cluster and how the third cluster was just behind and what it had. So moving on, just kind of what I found in this project. Just rehashing, these are the methods that I used, and for this predictive modeling. Just going back in regression, how regression was just not the right way to go about this project for this data set, modeling it. Very low R-squared, line of best fit, not very good for predicting, so I didn't really focus too much on it. Classification was the best. There's different methods, but it produced the best results that I had in my mind. Best one was 71% accuracy, almost 72. Produced 760 movies correctly predicted, and I thought that was very good. And then clustering. I felt like clustering overall was lopsided with its results in some of the clusters, but it was interesting to look at some of the clusters, like cluster 1 and cluster 2 and 4. They're just labeled differently because of the programming, but then the score at the end of the day was very different, and so I thought that kind of it's hard to kind of gain more insight on that. So highlights just from this whole project, just because you're trying to give the movie producers something to focus on and to highlight like what's important and what they can narrow and focus their resources on. And so just rehashing on using these models can help movie companies know what variables to look at, what's important. These were the variables that we found, as stated above earlier, that were important for movie success. It kind of skips a little bit, but it just kind of rehashes what I've been saying throughout, that for movie success, it's good to focus on those certain variables. Moving on with some of the other highlights of the project that I thought was important to rehash was some important features was like duration of the movie. This kind of led to higher scores. I thought that was important. Also, top directors. These are the top 8 directors. I thought it was interesting. Like Christopher Nolan was a big name that stands out. He had a score of 8.42, and so it wasn't just one movie; it was multiple. And these are some of the correlations for the genre categories. Action shows up on here twice, but that's just because in the code, action was tied in. This action was tied in with another genre, so it wasn't just a pure action film. It had some other tie-ins, which actually brought the score down. So just a pure action film was the top with the most movies. So some of these are higher, but for the most movies, this was the top, was action with that average rating. Content rating is also important. I won't spend too much time on this, but these kind of exclude certain audiences at the extreme ends, like NC-17 and X, and then G and PG. Ratings that have for a larger audience for everybody, those are the ones that did better. And then certain directors had just a lot better scores. Just kind of look at more directors with that. And just rehash is putting yourself in the best position as a movie company or producer, is just using what these models predict and using what these variables deem important. It doesn't necessarily guarantee success, but it gives you the best chances and odds of success when it comes to IMDB rating and score. And so using these helps you focus your resources and helps you do better and hopefully be more successful. So this is the end of my project. Thank you for listening and have a good one.